Ches Tobias, and the title of his talk is EXCELsioR.
How's it, guys? So I realize I've got the graveyard shift here, but promise it's not a super technical talk. Think of it as like late Friday afternoon, our bloggers. You have work, but you don't really have work. Yeah, I'm really stoked to be here, actually. I attended the first satRday in Cape Town back in 2017, and every year I really look forward to coming to this. There's so much to learn, and it's great fun for me. Who is me? This guy. I'm not a hardcore data scientist. I've never studied computer science or any of that good stuff. I barely know what Docker is, and I'm from Cape Town. But that landed. Thank you. But yeah, once I graduated, I started working as a quant in a fixed income team. So I've been in finance since 2015, and I'm now a consultant. It's a 3-man firm, so literally you do everything. You are all solutions at all times, which is great fun. But you also run into a couple of very interesting problems. Some of the stuff I want to talk about is why spreadsheets are important, how I wrangle untidy data from spreadsheets, the challenges that you will face with that, hard knocks. I've bumped my head a million times. Conclusions, and then at the end, some useful links if anybody's interested in either like corporate valuation, finance stuff, to tidy data, or whatever else. So what do I hope you get out of this? Really is that you take time to learn to love spreadsheets a little bit. I know I, at least on a weekly basis, want to kill my computer, even though it's got nothing to do with the spreadsheet. It can be super frustrating, but I hope that through the examples I run through, you kind of have an aha moment that's relatable, that makes you think, okay, well, maybe spreadsheets just aren't that bad. As guys that know how to code, for those of you in the audience that don't know how to code, just don't be disheartened by the fact that you're developing and doing stuff in spreadsheets, because you really are contributing some pretty cool stuff as well, and also you're keeping guys like me in a job. So let's press on with more of the meat. For any of you that are complete data nerds, you also listen to podcasts about data. There's a great one called Data Frame with Hugo Anderson, and he interviews Jenny Bryan on spreadsheets. And she says spreadsheets are like the English of the data world. Basically what she means by that is we all kind of speak it, whether you're a hardcore data scientist or just an average schmo doing his accounting. We've all seen or used a spreadsheet at some point in our lives. Most organizations, so I work in consultancy, and we deal with financial statements and data from guys in healthcare services, construction, resources, across a broad spectrum of industries. And a lot of them, almost all of them, are using spreadsheets to create, store, and disseminate their data. Even the bigger firms who have fantastic enterprise solutions are still using spreadsheets to do things that you think they really shouldn't be. It enables knowledge experts without the ability to code to contribute their expertise, which is fantastic. I've encountered super smart people throughout my career that they just don't know how to code, and I'm a better person for being able to consume their content, even though it's been written in Excel. So I think let's not dismiss what comes out of a spreadsheet, even though it may not be scalable, robust, and all the good things that we like from code. I think it's our job as guys who know how to program to make those good qualities better by coding them up. I think it's a great medium for prototyping. A lot of people might disagree with this, but you just get a block of cells, and it's like taking pen to paper. You can just do whatever you want and put it in a scratchpad script if you want afterwards, but you'll figure out where you're starting to reach your limits. And this last point I think is pretty important, is that it provides a veil of trust or familiarity to non-technical people. So in the type of work I do, you'll get data in a spreadsheet, and you won't be able to like disseminate your findings in anything else but a spreadsheet. They will not accept anything but an Excel spreadsheet. So knowing how to use and make good spreadsheets, I think is very important. So why tidy Excel? Well, I mean, from the presentation so far, I guess all of us are tidy noughts, or most of us are. You'll understand. You can use other packages like Read Excel, also contributed to by Jenny Bryan. But I like tidy Excel. It's really great for unstructured, non-tabular data. I mean, you'll find this like 9 out of 10 times when dealing with Excel. Things aren't going to be nice to deal with, especially from a data perspective. So I think I'm the only schmo that's not managed to get my Unicode to render in the PDF. But anyway, imagine emojis of frustration. So in your spreadsheet is for Read Excel, tidy Excel and Unpivotal helps you tackle charming features like data as formatting and data in the layout. We all know these kinds of problems, right? So you get a spreadsheet and, oh, things in italics mean something different to things in bold. And if it's highlighted in pink, that's a different thing. And so how do you approach that? Like, how do you make sense of really messy kind of data like that? So here's an example of a real balance sheet from a client that we have. And to the human eye, it looks fine. It looks neat. I won't say tidy. It's not tidy. It looks neat. And to an accountant, it's beautiful. It's good. But what are the problems with this? Well, one is you've got one sheet like this. It's got a balance sheet and an income statement. And then you've got 56 individual Excel files that have it. And now you have to munge all that data into one centralized location that you can use to do analytics on. All right, so fine, easy, right? Let's just put this all together in one place. But what are some of the places you're going to bump your head on? Well, this date, it's 30 September. That's going to be a string. Then underneath it's the year. That's going to be a numeric. So that's fine. You're going to have to figure out a way to make some dates going on there. You've got these duplicate IDs, so PP&E there and PP&E there. The one's got numbers, the one doesn't. You got dupes year, cost and cost, they're both the same. Dupes year, financial assets, but this is non-current, and then you've got current as well, also called the same thing. Missing data that's just not there, and missing data that's zeros. So it's just a bunch of stuff where it doesn't make it fun to tidy. Into tidy Excel, and you get this really, really nice output with one line of code. It's so cool to work with, and with standard dplyr verbs, you can actually do a ton with it. So it's tidy. Every row is an observation. Every column is a variable. I think we had that nice definition earlier on from Codd's third normal form that Hadley borrowed in his paper. And pretty much, I mean, you guys will be able to make a lot of sense off of something like this versus something like this. So then I do a bunch of cleaning and munging and whatever, and pasting it all together, and now we're in Excel world again. So the model that was written before I arrived was written in Excel. And it's a great model. I really like it. It's good. It's not scalable, and you can't like work with 56 or 100 or however many different spreadsheets all at once in Excel and then produce it in Excel again. So I've got to take it out of the Excel layer, work with it in R, and then put it back into Excel. Unfortunately, the next project will be to develop the model in R. But then when it's in Excel, you got to put it in the sort of pseudo-wide form. So it's wide because, well, wide is just nice to look at in Excel. It's easier to work with, and it's easier for humans to use and read. But it's also long in that I've got each of the file names, so you'll have however many different files with the same wide format pasted below each other. So when you're working with this in Excel, you just do a lookup. I mean, simple VLOOKUP and then match on date. And then you're just referencing data from there on. You don't have to do anything else with cleaning and things like that. So that's the model. It only contains logic. There's nothing to do with data. No inputting, no cleaning, no nothing. It only contains logic. So you calculate CFRO as like an economic return on investment. No PAT, stuff like that, things that you guys probably don't care about. But there's a link if you do at the end, some summary output. So it's just the basic design. Everything is housed in its own individual tab. There's no putting graphics with logic. If you have to put in a manual input, and let's face it, you probably will because you're in Excel, and that's what Excel users do. Just don't ever touch the logic. Don't do it. Don't put it in the input data that was generated in R. R has done its own thing, and here's the metadata for that. You can check which are actual values versus forecast, what are the maximum and minimum dates that you've captured from Excel. And then if you want anything manual, enter it in there, and the logic will pick up on it and know what to do. So it's, I think, from a spreadsheet design perspective, better. It's not perfect, and ideally I wouldn't want it in Excel, but that's the approach I've used. So what are the challenges? We've kind of spoken about most of them, but just kind of in summary, you've got these mixed object types. I mean, like, you'll have dates and numerics and strings within a column. Not fun. You'll have these Excel-specific errors like hash value. So you'd find that in like a numeric in Excel, but that'll read in as a string, so your whole column becomes a string. Getting clients to supply consistent data, this is a huge problem. It's like you'll get in a balance sheet on Monday. By Friday, they have revised numbers, and oh, guess what? That balance sheet looks different. You've written all this code to handle the 50 sheets of balance sheets, and oh, guess what? You can't use half of it anymore. So even consistently bad data is better than inconsistent data. If it's bad, you make a plan, and you've got a script to handle it, but when that changes, you kind of have to be flexible enough to deal with that. And so don't spend too much time kind of making these nice generalizable functions, but also like try to save some time doing that. Hard knocks. So remember this guy here? I moaned about duplicate IDs. And I was like, these guys, they write spreadsheets, they're accountants, they don't know what they're doing. Right. I know, I'll solve it. I can freaking code this thing up and spend hours. It's not a lot of code, but it took a lot of time to think about and make it like work for every single corner case that they had. Literally a month later, scroll right. Guess what? Duplicate IDs go away. We've got unique IDs over here. It's not perfect because not everything has a unique ID, but I mean, I could have saved a lot of time and effort if I actually just took the care to actually understand my spreadsheets, like not outright dismissing it as inferior because it's a stupid spreadsheet. It wasn't a stupid spreadsheet. It had some good things. So yeah, don't bump your head like me. Like, scroll right. So to recap, what have we talked about? Why spreadsheets are important? Well, why I think they're important. My workflow, kind of, not really, but just an example of what I do. The challenges and the hard knocks that I faced. So to conclude, I mean, Excel's going to be here to stay, I reckon. All of us have, in some shape or the other, worked with Excel. I think Megan's presentation was excellent, but she's also pulled in data from Excel, and that's, I mean, for most of us, we don't deal with petabytes of data. That's going to be the normal working world for us. We have to be able to use spreadsheets. We have to be able to know how to interpret them and to do scalable analytics with them. And I think that was a great presentation that demonstrated that. And a lot of what my work is dealing with it. And so I think we're very privileged as people in this community that we actually have the data to begin with, right? Because a lot of data that we do use wouldn't exist if people weren't inputting it in spreadsheets. And secondly, we're in a position to add like real value to that data and even turn it into information that people with non-coding skills just cheap cont do. So EXCELsioR, ever upward. And yeah, I wish that I had written a package called that. It's called EXCELR, boringly enough, but I think this presentation was like a good excuse for me to use it. And that's it, yeah. Those are my useful links if anybody wants to pull the presentation from GitHub. Yeah, that's it. Questions, please.